Imperfection in solid. Let us now understand imperfection in solid. A solid consists of an aggregate of large number of small crystals. These small crystals have defect in them. The defects are basically irregularities in the arrangement of constituent particles. The defects are of two types, namely point defects and line defects. Point defects are of three types: stoichiometric defects, impurity defects, and non-stoichiometric defects. Click on the corresponding buttons to learn more. Stoichiometric defects. These are the point defects that do not disturb the stoichiometric of the solid. They are also called intrinsic or thermodynamic defects. Thermodynamic defects are divided into four types. The first one is vacancy defect. The second one is interstitial defect. The third one is Frankel defect. And the last one is Schottky defect. Vacancy defect. When some of the lattice sites are vacant, the crystal is said to have vacancy defect. Schottky defect. Interstitial defect. When some constituent particles, that is, atoms or molecules, occupy an interstitial site, the crystal is said to have interstitial defect. Schottky defect. Frankel defect. This defect is shown by ionic solids. The smaller ion, usually cation, is dislocated from its normal site to an interstitial site. Schottky defect. Schottky defect. It is basically a vacancy defect in ionic solids. In order to maintain electrical neutrality, the number of missing cations and anions are equal. Schottky defect. Click on the corresponding impurity defects. One such example of impurity defect is introduction of cation vacancy in NaCl by substitution of two Na plus ions by one strontium plus 2 ion. Click on the non-stoichiometric defects. As you can see from the crystal structure, an electron has replaced the anion. This type of defect is known as metal excess defect. No more. Metal excess defect. Metal excess defect due to anionic vacancies. When crystals of NaCl are heated in an atmosphere of sodium vapor, the sodium atoms are deposited on the surface of crystal. The Cl- ions diffuse to the surface of crystal and combine with Na atoms to give NaCl. As a result, the crystal now has an excess of sodium. The anionic sites occupied by unpaired electrons are called F-centers. They impart yellow color to the crystals of NaCl. Metal excess defect due to the presence of extra cations at interstitial sites. Zinc oxide is white in color at room temperature. On heating it, loses oxygen and turns yellow. The reaction taking place is ZnO on heating gives Zn plus 2 plus half O2 plus 2 electrons. Now, there is excess of zinc in the crystal and its formula becomes Zn 1 plus X O. The excess Zn plus 2 ions move to interstitial sites and the electrons to neighboring interstitial sites. Now we will study about metal deficiency defect. A typical example of this type is FeO, which is mostly found with a composition of Fe.950. In crystals of FeO, some Fe plus 2 cations are missing, and the loss of positive charge is made up by the presence of required number of Fe plus 3 ions.